A thin 1.5 meter long aluminum wire of mass 0.2 kilograms carrying a current to the right is suspended above the ground by a magnetic force due to a uniform magnetic field. In other words, this wire is just floating in the air. On the diagram, show all the applied forces on the wire. What is the net force on the wire if it is in equilibrium, so it's just floating there, not moving? What is the magnetic force on the wire? Then show the direction of the magnetic field and find the magnitude of the current flowing through the wire. Start with a free body diagram on the whole wire, and we're going to have it acting right here. We should have put a dot here, right? So we have gravity pulling it down, mg, but since the wire is not moving, we need a force in the up direction. It's exactly equal to the gravitational force. So that's going to be our magnetic force. What is the net force on the wire if it's in equilibrium? Almost a trick question. But equilibrium means that the wire is not accelerating. So that means the acceleration is 0. And we're looking for the net force, which is the sum of the magnetic force and the gravitational force, so that will be 0. What is the magnetic force on the wire? Okay, we'll start with Newton's second law. Sum of the forces is ma. And from our free body diagram, we have two forces. We have one in the up direction, so we'll call that positive. That's the magnetic force. And we have gravity in the downward direction, so that's negative. And their sum is 0 because we're in equilibrium. Do a tiny bit of algebra and math. The magnetic field equals mg. Finally, put in our numbers, and we have 1.96 newtons. Since the net force is 0, the magnetic force is equal to the weight, which is mg, of the wire. On the diagram, show the direction of the magnetic field. We're going to use the right-hand rule. Put the 4 fingers of your right hand pointing in the direction of the current. That's to the right. Here's the current right here. Your thumb then points in the direction of the magnetic force, which is the top of the page. Just leave your thumb straight, don't move it. Then curl your fingers 90 degrees to point into the direction of the magnetic field. That will be into the page. So into the page is our answer. And if you don't want to curl your fingers, you can just say, hey, where's the palm of my hand facing? And that's facing into the page. Very important note here. This question is asking about the external magnetic field, not the magnetic field caused by the current in the wire. What is the magnitude of the current flowing through the wire? We have an equation for that. The magnetic force is equal to the current times the length of the wire times the magnetic field, and a handy way to remember that is Philb. It's a nice sounding name. We're solving for current. So current is equal to the magnetic force over the length of the wire times the magnetic field. We already found the magnetic force on a previous slide. Put that in. Here's the length of the wire. Magnetic field is here, and we get 0.93 amps.